Hey, it's Phil from My Math Teacher is Terrible. Thanks for joining. After I recorded a really long video on understanding percentage calculations and then some examples, I realized that I really had to cut this video into multiple parts. I think 2 parts is going to be good. One where I just described the basics of how to deal with percentages, and then sort of part 2 would be more about applications and some shortcuts. But since you've tuned into this one, this is going to be the rudimentary one about the basics of how to use percentages and kind of what they mean. And then would love for you to tune into part 2. Could be a 3rd part, not sure yet, but I think it's just going to be 2 parts about applications of how we use all this stuff. So take notes during part 1 and try to use your notes during the successive parts. Thanks so much for joining. Without further ado, here is part 1. Hi everyone, I'm Phil from My Math Teacher is Terrible. Thanks for joining today. I figured that today we would actually talk about a topic where I feel like many math teachers are terrible, and perhaps yours is too. And that is dealing with percentages, how to calculate them, how to solve problems that involve percentages, how to just kind of think clearly about what's going on with percentages in sort of everyday life. I feel like there are a few very simple calculations that can be made and some very simple ways to reason about things and think about them so that they actually make some sort of sense. And that's what we'll talk about today. I expect that this video might have a bunch of cuts in it as I deal with certain topics, but you'll see I'm the master of the crossfade when it comes to editing these things, I hope. Okay, so let's just talk about the basics. First, with no sort of mathy language, or very little anyway. I'm not going to actually get into like a calculus topic here to talk about percentages. We're going to talk about them in very simple ways, and probably nothing more advanced than Algebra 1 or Algebra 2 in terms of what these things mean. So what simply is a percentage? A percentage is any fraction with a denominator of 100. That's the easiest way to think about it. And watch how I do this. If I want to actually express a percentage as a fraction, how do I do it? What is 25% as a fraction? Watch how I do it. 25%. Right? So the key thing here is, and actually for the first few times, and maybe forever, who knows? Say this to yourself as you do it, right? This is per. Is drawing the horizontal line, right? 25 miles per hour. But here, 25%, and cent is 100. That's all. That's absolutely all. To take this just another step further, what do we usually do with fractions when we have a problem on a test, and then we say that x equals 25 over 100. Well, generally not accepted sort of in this form as an answer. Why? Because it's not simplified. Right? I see that I can actually take this fraction and reduce it. This fraction can be divided by 25 on top and bottom. So 25 into 25 is 1, and then 25 into 100 on the bottom is that. Done. What is 25% as a fraction? 1/4, because it's 25%, and then I reduce, right? Reduce. That's all. There's actually nothing more complicated. This is the basis of what percentages are. I can express any fraction, I can express any number as a percentage. And then we'll see how this kind of thing is used, right? We use it in sales all the time. I took a certain percentage off the price of a pair of new pants that I bought. I'm a real estate broker. My commission is a certain percentage of the sale price of a house. Blah, blah, blah. There's tons of things. And I feel like a lot of my students freeze up when it comes to something like this. And if you're in high school and you're about to take the SAT exam, there's usually some sort of question about percentages and like how to deal with them on the exam. But again, I really am here to tell you it's actually not hard. You've heard that from terrible math teachers, but I'm helping. And I'm actually going to try to describe these sorts of things in very, very simple terms. Now, forget about this junk. If somebody asks you what 1/4 is in terms of a percentage, what can we do? Again, I need to simplify, I need to express 1/4 in terms of a percentage, right? But I don't know how to do that, right, in my head yet. Okay, so let's create a simple equation. I don't know what the percentage is, so what do we say when we don't know a value? We call it x. Fair enough. So how would I get x by itself? Multiply both sides by 100, right? I want to get rid of this denominator here. Let's do that. Times 100 on both sides. Times 100 on both sides. So the 100s will cancel, right? Leaving me with x. And then here, this is nothing more than 100 over 1. And when I multiply, I go straight across the top, straight across the bottom for fractions, right? So it's 100 times 1 on the top and 1 times 4 on the bottom. Awesome. Again, this is a fraction. And a fraction is nothing more than a division. It's a division problem. It's a way to express dividing two numbers. This is 100 divided by 4. If you don't know that off the top of your head, type it in the calculator and see what happens. 100 divided by 4 is 25. Right? So this tells me that my fraction here is actually 25 over 100. Right? But now let's write it using my sort of mnemonic here, right? Let's write this same fraction exactly the same way. 25%. Done. That's all. The process that I used here is not much different than when I ask you what is 1/2 plus 3/7. What do we do here when I actually need to add these two things? I got two different denominators, right? Going back to basic fractions. First thing I do is get a common denominator. Right? And there's various ways to do it. The easiest way is to multiply the two things, blah, 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 and we can solve this. This is the same thing. I was given 1/4, and I asked what is 1/4 with a denominator of 100? Because we're dealing with percentages. That's all. So I actually unreduced 1/4. Right here, I reduced 1/4. That was the final part of my answer. But if I look at the equal sign in this direction, I can start with 1/4 and go this way. And when I do go this way, I actually unreduce it, right? I don't care that it's reduced for this problem because I want to know what the top is. And the top is the percentage. Right? I just took the top here and said that it was 25. And then I just said that it's 25%. 25%. So it's 25% is 1/4. That's all. Nothing more and nothing less. That's it. Okay, we can use these ideas to actually perform calculations. Again, we're reducing when we start with a percentage down to some sort of fraction, whatever the heck it is. Or we're unreducing when I start with 1/4, 1/4, and I want to go to something that has a denominator of 100 because it's percent. I can express any darn thing I want with a denominator of 100. Absolutely. Let's see how we might use this, or let's take a look at the common problems that we get when we're dealing with percentages. The other thing is, as we do this, we're going to actually have a look at, I'm going to write a sentence, and then I'm going to translate it into math. And then we'll see like how simple this can be. Okay, now we're ready to talk about some simple problems. The first type of problem is something like 25% of 35 is what? And I'll just write it. I'll just write it as you would see it in your book or in your homework or whatever. 25% of 35 is what? And there's some key components to this. There are three places that have numbers. Here, here, and this is going to also be a number. And I can take this exact sentence and translate it into a mathematical phrase very easily. Let's do it. 25%. 25% of means multiply. And actually, I'm not going to use the multiplication symbol. I'm going to use the dot because we're going to use x as our variable and it gets very confusing. Multiply of 35. Nothing I can do with that. Is equals what? And when we have a what do we call it? That's right. So these things get translated directly. They're 25% of 35 is what? That's all. Now we have some math to do, right? Hooray for that. 25%. Okay, so, and I'll just write it. 25% times 35 equals x. There's not even any algebra to do here because x is by itself already. We have just the calculations. So I'll make one simple change. Of course, a whole number as a fraction is this over 1. Correct? Okay. And now I'm going to multiply straight across the top, straight across the bottom, because that's how we multiply fractions. 25 times 35 over 100 equals x. All right, and then I'm going to grab my calculator. I could probably do that in my head, but let's not. 25 times 35, magic calculator says it's 875. This is 875 over 100 equals x. All right, and now here's a simple trick for dividing by a power of 10, dividing by 1, 10, 100, 1,000, etc., etc. How many zeros do I have? I have 2 zeros, right? I have 2 zeros. So if I'm dividing by 100, I really want to just write whatever the numerator is, 875 as a decimal, right? And then if I'm dividing by 100, I want to move the decimal this way, right? I want to go 1, 2 for the 2 zeros. So this is here. So 8.75 equals x. And this means 25% of 35 is 8.75. That is all. All we did was translate the English to a math equation. Right? It has an equal sign. Equations have equal signs. And this is just basic algebra. Then I just simplified the equation by writing 25 over 100 times 35 over 1 equals x. And then I actually just did this stuff in the calculator or in my head, depending on how awesome you are at mental math. But that's it. So here, 8.75 is the answer. That's all. Does this make sense is the next thing that we should actually talk about just for a moment. And that is 8.75. Let's use our estimating skills. 8.75 is nearly 9. Right? Let's say that it's 9. And we also learned just a moment ago that 25% is 1/4 as a fraction. So that means the check is, if I multiply 8.75 by 4, do I get 35? I don't want to pick up the calculator again. I'm going to estimate. 8.75 is nearly 9. If I multiply 9 by 4, do I get close to 35? 4 times 9 is 36. Pretty darn close. So it actually makes sense in the context of our problem. And again, what is it? 1, 2, 3, 4. And then a simple division trick. This is one step, more or less. 5 steps, not so bad. Okay, it gets even better. All right, so let's erase this. Let's erase this part here, and I'm going to show you that it gets even better. That's one type of percentage question, right? I'm going to tell you that this phrase produces 3 types of questions. And here's how it goes. I'm just going to leave my little red blank spots. And really, we just are moving around the unknown. We're moving around the x. Oh, I should have left the percentage here. Let's do that. Okay. So the x was here last time. Right? The x was here last time. So now I'm going to put the x here. 13% of x is 41, I guess. Let's use 2 prime numbers. It'll make it terrible and exciting at the same time. Okay, so I want to know this, right? They're asking 13% of what number is 41? Right, so when I take 13% of this number, I get 41. That's all this is asking. The only thing that's different here is now the x is here instead of at the end, as the previous problem was. Great. Let's write it out as an equation. 13%. 13%. Per is the line, right? 13% is 100 of multiply x, right? Is equal sign 41. Right? So all I did was take this and translate it directly to this. 13% of x is 41. Okay, now the translation part is done. Now we got to do some algebra. Fair enough. I'll just consolidate this a little bit. Get rid of this. I'll do 13 over 100. X equals 41. Okay, now what? Well, I've got to get x by itself. So I've got to multiply both sides by 100, right, to get rid of this denominator here. So I'm going to do that. Okay, these will cancel, and I get 13x equals 41 times 100 is 4100. And just like dividing by 100 was moving the decimal point this way, multiplying by 100 is moving the decimal point that way. 41, 1, 2. Or just add the number of zeros right on the end. Super easy, not difficult. Just try to remember these little tricks. Okay, and now to get x by itself, I divide by 13, right? And the 13s will cancel. I get x equals, and the magic calculator is going to tell me what? 4100 divided by 13. 4100 divided by 13. And this number is 315 point blah, 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 a little bit of a long decimal, but I'm going to just take it to 2 places. This is 315, man, terrible 5s, point 38. Okay, fair enough. Now, let's see what happens. When I put, and simply to check my answer, I have to put 315.38 here, right? Okay, so this says that the answer is 315.38. So let's see if that actually is true. And 315.38 is an estimate, but I'm going to erase this because this is our solution. And now we're going to plug our answer back in. Does it actually make sense? Okay. Let's do it. Okay, so now 13 over 100, right? 13 over 100 times 315.38 equals 41. We're asking, is that true? By checking our answer. All right, 13 over 100. Let's use our dividing by 100 trick. This is 13, but dividing by 100 says move the decimal point this way. So it becomes 0.13. And this is the way to translate a percentage as a fraction into a decimal. You just divide by 100. Okay, fine. Times 315.38. Does it equal 41? I don't know. Let's ask the calculator, right? Okay, so 0.13 times 315, whoops, I forgot the times, times 315.38. It is 40.994. 40.994. And since I started off with an approximation, I really have to make this an approximation. This is approximately 41. Right, this is approximately, which is the squiggly equal sign, 41. And that's correct. So 13% of this number is 41. That's all. Again, the difference between this and the first problem we did was I just put the x in a different place, but I wrote this equation exactly the same way as I did the first one. All right, one more. I said there were 3 variations. Let's look at the third one. Let's see. Okay, let's erase the solution to that problem. And now let's do the third variation. Maybe pause the video and see if you have a guess about what the third variation is going to be, and then see if you're right by unpausing. But again, here's my blank spots, right? Here they are. Okay. All right. Now, let's talk about the third variation. So far I had the x here. Last problem I had the x here. And you guessed it, now the x is going to go here. And then we'll have all the variations of this type of problem. So they usually say, what percentage of 412 is 17? Right? What percentage of 412 is 17? Whoops, I'm not going to do a question mark. I'm going to use a variable like mathematicians do. Right? X percent of 412 is 17. That is, I take some percentage of 412 and I get 17. All right, let's write it out. It's the same exact thing that I've been doing the entire time. X percent of multiply 412 is 17. It's the exact same equation. Last problem the x was here. The first time the x was here. That's it. That x is just moving around. And there's nowhere else for x to go after this version. So there's 3 versions of this phrase in English. And now here's the third one. All right, let's get to work. X over 100 times 412 is 17. Okay, so to get rid of this denominator, multiply both sides by 100. Okay, the 100s will cancel. And this is going to be x times 412 equals, and here's, let's use our trick. 17 times 100 is 1700. All right. X times 412 is the same thing as 412 times x, right? In the same way that 3 times 5, 15, equals 5 times 3, also 15. So I'm just going to rewrite this so that it maybe looks a little more familiar to you. 412x equals 1700. All right, this is exactly the same. These are equivalent. We usually use the 3 bars to say that they're exactly the same thing. Okay, 412x equals 1700. Divide both sides by 412. And I'm going to take out the calculator because I don't really know. But actually I can think about estimating in my head, and here's how I would do it. This is about 400 on the bottom, and this is 1700 on the top. All right, let's take it over here for a second. If I do 1700 divided by 412, this is approximately 1700 over 400, right? When I divide these, the 100 parts will cancel. And this equals 17 over 4. What is 17 over 4 in my mind? That's approximately 16 over 4. And I know that this equals 4. So let's see if my incredible estimation skills and my crooked writing, gravity's pulling me down for some reason. Let's see if my estimate is good. So these 412s will cancel, right? And x will equal 1700 over 412, calculator. 1700 divided by 412, 4.1262. So 4.1262, which is approximately 4.13. Man, I'm super close, right? So that's the other thing, is like, as we kind of mess around with numbers, like dealing with percentages, like seriously, you've always got 100 in here someplace that you can mess around with, right? That seems to be, it actually is the core of dealing with percentages, because we have some sort of 100 like bopping around here. Right, if it's down here in the denominator, I'm eventually maybe going to multiply by it, blah, blah, blah. Therefore, I use the multiply trick here. 17 times 100, 17 with 2 zeros. And then blah, blah, blah divided by 100 is, here, I purposely chose 400 because it has 2 zeros, and they would cancel with those on the top. 17 over 4. So as you get used to calculating, I don't actually do mental math very well. There are certain things that I do very well mentally, but there are other kinds that I don't do so well. And just find where your strengths are, man, and then check out your calculator when you need to be able to calculate things that are a little weird. But what I really am doing here is going, okay, I'm estimating what I think my answer should be, and then I put it in the calculator and I get the answer. To a certain number of decimal places. This probably is a repeating decimal, so I'm not quite sure where this thing ends, but I chose it as an approximation here. Okay. So we got 4.13 as our answer. So we're saying 413. No, that we're not. Yeah, 4.13. We are saying that. Okay. Great. And that's pretty weird that these are sort of coincidental here. That's kind of interesting. We'll leave that to the number theory guys. All right, so now we're going to check to see if our answer makes sense. And then we're done with the 3 phrases. Like, I promise you, that's how we do it. That's it. There's just 3 ways to do this, and they're all the same equation. You just have to figure out how to solve them. Okay, now we're going to do the check. So here I say, and watch what happens here. Super interesting. 4.13%. 4.13%. There is no reason that I can't say this. Right, this is some number over some number as a ratio, as a fraction. If you type this into your calculator, this really means 4.13 divided by 100. Type it in your calculator. It's not going to blow up in your face. Like, it's going to give you an answer. That's another thing, is like, we actually, math teachers don't talk about things like this very much. But we can absolutely do this. Okay. 4.13%, right, of multiply 412. Is it 17? I'm asking. Okay, great. So let's deal with the fraction first. And actually, I don't have to deal with the fraction in the calculator because I'm awesome, and so are you. Here we go. Let's use the trick. It means if I divide by 100, I am going to move the decimal point this way 2 spaces. All right, I have 413. My decimal point is here, so I'm going to move it back 2 places. All right, 1, 2. So 0.0413. And this is always the case. I guess we can talk about that a little bit later. But this is, times 412, does it equal 17? Okay, so 0.0413. Let's see what happens. 0.0413 times 412. All right, and the calculator tells me it's 17.0156. All right, and this is to 2 decimal places. This is 17.02, right? Is approximately 17. Yes. All right. Done. When I say done, I really mean done. Those are the 3 ways to calculate percentages using this phrase. And I guarantee you that in your math class, you actually have had this phrase all 3 ways. And there's absolutely no reason to freeze up. Actually, there's one reason. You haven't practiced. And absolutely, if you practice dealing with this phrase with the X in various places, you will see that you're going to loosen right up and you're going to do just fine with the stuff. Okay, so I'm going to actually summarize this. I'm going to show the 3 different kinds of equations that we talked about. And if that helps you, then great. Write them down and then use them in your studies. Okay. So I think here I'm going to do something like label the positions that the x's can be in. Here's 1, here's 2, and here's 3. And then I'm just going to write the 3 equations so that you can see what they look like in summary. All right, let's get rid of this. All right. So equation number 1, let's start with that one. 1. The x is going to be here, so it's going to be x% of some number, I'll just put the 2 here, is 3, right? So for number 1, the x is here. The unknown is in this position. And whatever this is gets just written straight down. And this gets written straight down. Okay, so when the x is in position number 2, I'll have whatever is in 1% times the x is in position 2 equals 3, whatever's in position 3. Simple. And then the third way is that the x is over here. So whatever the number at 1% times 2 is x. All right, so what we see here is that the x just moves in the equation to 3 spots, as I promised and as I showed. Here's 1, here's 2, and here's 3. And each of these corresponds to how we would handle this equation. That is all. When I write a number in a circle like this, it means it's provided in the question. Right? So x is not provided in this space because this is not provided in the question. X is not provided here, and then here x is not provided in the third space. When I write the 1, 2, and 3 in the circle, I'm showing that those are the numbers that are supplied in the question. That's all. These 3 equations are the basic way that we handle these things. All right, so that I hope removes the mystery from that type of question. There are other types of questions as well. Hey, it's Phil from My Math Teacher is Terrible. It's the next day as I'm editing the now 2-part series on calculating percentages and applications. I realized I did not have an outro at all for part 1. So I just wanted to add something real quick to say thanks for joining and thanks for checking out the video. Please comment below and subscribe to my channel. Tell your friends, tell your terrible math teachers, and even tell your good math teachers to have a look and see if they find something that they can use and that helps out. Stay tuned for part 2 where we just discuss applications and we just kind of go from there. Thanks again, and I hope that you come back and view some more of my content. Thanks very much.